Cutting-edge technology has allowed designers to develop architecture that responds to environmental stimuli in more interesting ways than ever. In the current context of increasing environmental concern, architects and engineers have sought to redesign building envelopes to improve their environmental performance. Our project mentor's preliminary studies focus on the fabrication and testing of bistable laminates that exhibit a snap-through behavior with a small energy input. By combining these bistable systems with other smart materials as actuators is a strategy for kinetic building shades applications. The bistable system that we use is a carbon fiber sheet. Here, listen to it snap. In collaboration with the PSU Convergence Center for Living Multifunctional Material Systems, our team has been tasked with the project's Smart Kinetic Systems, actuating snap-through facades with responsive polymers. Hi, my name is Costantino, and together with my teammates, we completed our senior capstone design project. Our project is preliminary research in the larger agenda that seeks to develop kinetic shading systems using smart materials. To summarize our objectives, we were tasked with creating a series of prototypes that combine the responsive polymer actuators with bistable composite sheets. The prototypes needed to experimentally optimize location, geometry, and number of responsive polymers. Our first task was to define reliability testing. We began by manually actuating the sheets with basic magnets. From this initial interaction, we determined that we needed a testing setup and a stronger magnet. Thus, we developed a testing frame that can hold 4 sheets at once and uses what is called a boundary condition to hold the sheets in place. We used a coordinate system to determine optimal MAE location. These optimal locations turned into zones. Zone 1 produced the best results. For further testing of MAE shape, we found that a square of 0.7 by 0.7 by 85/10,000ths of an inch was least stiff and best for actuation. Next, we optimized the number of MAE by thickness and surface area testing, using a paper collar to measure the distance of the magnetic field needing to actuate the sheet. The video showcases successful actuation of 4 bistable sheets in its testing frame. Although our project was just the beginning of a large operation, we tried to emulate a building facade by placing it in a similar setup, by shining a flashlight at our final prototype in each configuration to see how much light was allowed through.